Okay, for the second part of this lesson, we're going to look at chemical and physical changes now. The first one was over chemical and physical properties. This is closely related, but this is chemical and physical changes. So we're going to start out here talking about a physical change. Notice that a physical change is a change in size, shape, or state of matter. Okay, so it doesn't alter the identity of the substance. It's still the same stuff. It's just changed form. And so examples of this be like tearing. Okay, if I take a piece of paper, tear it in half, it's still paper, right? Same thing, crushing. Crushing is taking, it's like taking a big piece of rock and pounding it into smaller pieces. It's still the same mineral composition, it's just in a different form. All these next things, crushing, or excuse me, condensation, melting, evaporation, dissolving, freezing, boiling, all of those things are changes in state or phase changes. It's important to note that the chemical composition, like I said, does not change. It's still the same substance. Um, and it's usually going to be reversible. And when I say reversible, that means that I can undo it easily. Okay. I do want to show you something with these changes of state or these phase changes, condensation, all this stuff. We're going to look at just this simulation I have pulled up here, this PhET simulation called States of Matter. Okay, so we're going to start out here maybe in like the solid form. And so you'll notice here I have a bunch of looks like neon atoms. Notice how they're all kind of stacked in there tightly together. They are moving, but they're just kind of vibrating in place. But they aren't able to really flow past one another. So if I add a little heat to them, I'm going to put a little fire on here. Okay, you're going to notice now that the individual atoms have enough energy that they can move and glide and slide past one another. They're no longer in that square shape. They're kind of, some of them are spreading out. And so in chemistry, we would say that that state of matter, it melted. It went from a solid phase, and now it's a liquid. It's able to flow. The particles are able to move, but they're still packed in there tightly together. If I continue to add a little more heat, you're going to notice that these particles begin to spread out, and they're going to expand, and they're going to fill that container. Okay, so what that liquid did, that liquid evaporated. Okay, it vaporized. They went from a liquid phase into a gas. You'll notice that they're really spread out, right? They're far apart from one another. They have, it looks like no definite volume, no definite shape. You can compress them, you can squeeze them together. Okay, they're just moving around, bouncing off the walls. And so those particles evaporated. Okay, now instead of putting heat on there, I'm going to put some ice cubes. We're going to cool down this container of gas. What you're going to notice that these gas particles start slowing down. They start kind of sticking together. Okay, they start kind of adhesing to one another. And they're going to kind of group up here at the bottom, kind of falling down here. But notice they're still pretty energetic. So that would be a liquid once again. So when you have a gas turning back into a liquid, that's condensing. Okay, condensation. Those gas particles have condensed down into a liquid. Notice they're packed in together once again. They're still able to flow and glide past one another, but they're moving kind of freely. If I put a little more ice on them, notice there they go. They froze. Freezing. Okay, when a liquid becomes a solid. Notice they're packed in as tight as they can be. They can't move past one another anymore. They're just kind of sitting there, vibrating in place once again. So these are all important states of matter. And so, like what we were just talking about, the particles in the solid, like we said, are packed close together. They cannot move around. They're kind of locked in place. They do have a definite volume, means they're packed in. Definite shape, they can't move. You'll remember the liquid particles are still packed in close together, but they can flow past one another. So they have a little more energy. They're able to glide past one another. They do have a definite volume. They're still packed in close together, but they take the shape of their container. All right, they can flow and glide and move around. And then finally, we said the gas. Gas is particles that are spread far apart, moving in all directions rapidly and randomly. They expand and fill their container. They have no definite volume, no definite shape. And just to kind of remind you of some of these terms we just talked about, we're going to look at the solid liquid gas business here. Let's see. Let's make this pen skinny. Okay, so if we have a solid that turns into liquid, we said, oh, that substance melted, right? Went from a solid to a liquid. Think of like water, okay? Solid water or ice turning into liquid water. You say that ice melted. Likewise, liquid going into a gas. Liquid going into gas, we call that evaporation or vaporized. Okay, vaporized became vapors. Likewise, you can have a gas turning into a liquid. Okay, gas turning into liquid, we said that it's condensing. And then finally, liquid turning into a solid. That's freezing. Okay, so all of these, we're going to say phase changes. Or we're going to say changes in state of matter. It's important to note all of those are physical changes. It's still the same substance, it's just how the particles are arranged, how they're rearranged. Okay, chemical changes or chemical reactions. The thing about chemical reactions or chemical changes that the composition does change. So it turns into something new. All right, new substances are formed. It's usually not going to be reversible. Okay, once you've done it, that matter has been changed and it's changed into something else. You usually can't get the beginning material back from it. These are all indicators that a chemical reaction has taken place or chemical change. So certain things like odor change, okay, change in smell. I'll give you an example. Let's say this: if I take a piece of wood and I burn it, that is a chemical change. Right, I'm chemically changing the wood. It has an odor change. So think about that. If I take a piece of wood and you smell the wood before you burn it, wood has a particular smell. And everybody knows what wood smells like when it burns. It smells, like a campfire. You can tell, from a long distance that wood's burning somewhere because it has a definite odor, and the odor changes. So that's one indicator there is a chemical change taking place. Gas formation. Okay, this is going to be largely bubbles or fizzing, because a lot of times these chemical reactions are going to take place in solution, like in water. And so as that gas is formed, you'll see bubbling or fizzing. You can kind of see gases that are rising off. Like, let's go back to our campfire. You can't really see the gases, they're invisible, but you can see the gases carrying unburnt particles of ash and stuff with it. So you can see the smoke. So you can tell there's a gas there. There's something carrying those particles away. So formation of a gas is an indicator of a chemical change. A dramatic color change. When you take wood and you burn it, it looks different. Okay, it turns black. So when things change color, that's usually a pretty good indicator there's a chemical reaction taking place. Change in temperature, either something getting hot or getting cold. Once again, thinking back to these burning logs. One of the reasons why you burn logs is because they give off heat. As it undergoes those chemical changes, it releases that energy that's stored in chemical bonds. So changes in temperature can be indicators of a chemical change. Light or sound given off. Okay, you've been by a campfire, it definitely gives off a little bit of light. You can even hear it kind of popping and fizzing and stuff, so it does produce sound. The last thing is talking about a precipitate may form. Okay, let's see. I need to tell you kind of what a precipitate is. That's not going to be related to a fire. So a precipitate, you have like two clear solutions are mixed, and they form a like a milky or a cloudy solid. Okay. Usually they're white, but sometimes they're other colors. I can show you a little snippet here of a video. Okay, here in this video, you see some lead iodide precipitating. Clear liquid here. Here's a clear liquid. You're going to notice it drops down into here. There's your milky precipitate. This one happens to be very striking, very bright yellow, but it is, that's what a precipitate looks like. Okay, two clear liquids turning together, you see a milky precipitate. Okay, here we're going to do just a real quick review, looking at physical or chemical changes. Melting ice in the street. So once again, anything dealing, with changes in state is going to be physical, because think about ice melting. Okay, that ice melts, turns into water. If it gets cold again that night, it refreezes, turns back into ice, so you can undo it. Definitely going to be physical. Burning gasoline, that's going to be chemical. Anytime you have something burning, because you have light, heat, smells, new substances are formed, you can't get the gasoline back. Same thing, metal corroding on your car, that's like rusting, that's chemical. You can't get the sheet metal back. If you ever watch any of those shows on TV that are popular right now, like Fast and Loud, where they go and find these old cars and sitting somewhere in barns and things, they're all rusty, and they'll take them and they'll fix them up and sell them for a profit. Well, if the car has rust on it, they can't just grind it out. They have to cut out that section and weld in new metal, because that iron is gone. It's corroded. It's turned into a new compound, iron oxide. It has different properties of iron. Breaking a window, that's going to be physical. Okay, because what you have is, if you put a baseball through a window, it's still glass. Okay, it's still the same silicon oxide compound. It's just in a different form. You can actually reform it into a window. They recycle glass all the time. They heat it up and pour it into whatever new glass product they're gonna use. Let's see, water condensing on a window pane. Once again, we have that term condensing. Condensing was one of those changes in state. Changes in state are all physical changes. Dissolving sugar in water. Dissolving is a weird one, okay? Sometimes dissolving is chemical, sometimes it's physical. You have to know what's dissolving in what. So in this example, sugar dissolving in water, this is going to be physical, because it's still sugar, it's still water. If you boil the water off, the sugar remains behind. If you've ever made like rock candy, that's kind of the process how you make rock candy. You get a saltwater solution, you boil it, and you put like a stick or string in there, and the sugar will recrystallize on that string. So that would be a physical. If I had something like a penny dissolving in acid, that's chemical. Okay, because there'd be bubbles and change in color, and new substances being formed. So you kind of have to know, and know what you're looking at. So dissolving in sugar and water, that's going to be physical. Burning a candle, chemical. Light, heat, smells, all that stuff. Okay. So what I'm going to have you guys do now, I'm going to assign you guys a worksheet, and I want you to go through and do some practice on chemical physical properties, chemical physical changes. Go ahead and I'm going to have you do this today, and then I will post the solution. I'll give you maybe a key to it, and then I'll probably also make a little video where I explain kind of what's going on. But that's going to be your assignment, is to go through and look at the chemical physical properties, chemical physical changes, practice those. We'll probably have a short quiz on that here in a couple of days. Okay? All right. Well, thank you.